Okay, guys, so you remember this is the problem we were working on in the first part of section 5.2. We're looking for the centroid. This lady wants to balance some metal triangles on a stick, and she's looking for the centroid. And so if we took one of her triangles, we threw it on a coordinate plane, we see that it's going to lie like this with these black points. We know that the centroid is created by finding the median, the place where the medians intersect. So in order to find the medians, I needed to actually find the midpoints. You guys remember how to find the midpoint? I'm going to talk about this purple one in a minute. The purple midpoint between 110 and 50, we would add up the 5 and the 1, get 6 divided by 2, we get 3. Add the 10 and the 0, divide by 2, we get 5. Therefore, 3, 5 is the coordinate of the midpoint of this segment with endpoints 110 and 50. And similarly, I found the other ones. So this midpoint is 5, 7.5, and this one is 7, 2.5. So now we need to find the equations of the line and find the intersection of them. So they're asking us to do some serious algebra today. And we're tough. We can do it. So I'm going to draw my purple line, my purple median, and we're going to find equations for each of these guys. My red median, and then I have a green median. And then so once we find the equations of all of these lines of each color, what we're going to have to do is find where they intersect. So we've got a purple equation to look for, we've got a green equation, and we have a red equation. All right. The fact of the matter is that our algebra skills did tell us back in the day that when we find this, we can look to find y equals mx plus b, form of the line where m is the slope and y is the y-intercept. Remember that? And so the first thing I would do with any of these segments is I'd look for the slope. So this is just one way to find the equation of the line. We also have point slope form, which I'm not going to get into right now just because of time, but we can find the slope of this line. And when I look at this, the change in y over change in x, there is no change in y, meaning my slope is 0. 5 minus 5 would be 0 over 9 minus 3, which is 6, but 0 over 6 is still 0. And so my slope is 0, which tells me when I plug it in here, the x, the whole mx term goes away because 0 times anything is 0. So I'm going to end up with this equation will be in the form y equals b, which means it's a horizontal line, which it looks like, right? And what's the equation of the horizontal line? It'll just be whatever the y-intercept is. What's the y-intercept going to be? Well, if all of the y's in this equation are 5, and these points are 5, we can safely say that y equals 5 is the equation of this line. I'm going to do the red one next because something interesting is happening here. If I were to go in and try to rock a little y equals mx plus b here and look for the slope, I get that my change in y is 7.5, right? And my change in x is 0, which means I have an undefined slope. Undefined equations have a specific equation, and that equation is that x is equal to some value because it's a vertical line, and in this case clearly we can see that x is equal to 5. That has really made our lives easy. In fact, it has given us the answer, right? Because if y is equal to 5 for all of these guys and x is equal to 5 for all of these guys, clearly 5, 5 is the answer to the question. I'm going to actually just find the equation of this line. 5, 5, like 5, 5 is legit it. Like we found it. The centroid is 5, 5. It has to be because this equation says only the x's for everything on this line is 5 and the y's for everything on this line is 5, and therefore it has to be 5, 5. I'm going to first find this equation of this line, and I'm going to check this 5, 5 answer. So how do we do it? Again, we're going to rock a y equals mx plus b. We'll find the slope. Slope is change in y over change in x. So if I'm looking at the green equation, 10 minus 2.5. So I'm going to go this way. 10 minus 2.5 is equal to 7.5. And 1 minus 7 is a negative 6. I don't like this decimal whole number business, so I'm going to multiply top and bottom by 2 to create an equivalent fraction that is just easier for me to deal with. So when I multiply this by 2, I get 15. The denominator by 2, I get a negative 12. Therefore, negative 15/12 is my slope. Or I can look at this as reduce that, divide top and bottom by 3, negative 5/4. So that's how I got my slope, -5/4. These are all equivalent fractions. So the next step of finding an equation in this form using y equals mx plus b is now to plug in the slope. So y is equal to -5/4 x plus b, and we need to find b. So to do that, we take any one of the 2 points that are on the green line, and I'm going to use the point 110 just because it's like the nicest point and easy to substitute in there. So I substitute 10 in for y is equal to -5/4 times 1 plus b. And so now I have everything but b, and I'm going to solve for that. So I have a -5/4 that I'm going to bring over to the other side. So I get 10 and 5/4 basically, which is weird, is equal to b. I'm going to write that in a better way. 10 and 5/4, well, I got a mixed number here, which is going to be 1 and 1/4. So that means that's 11 and 1/4, or 11.25. So if I were to continue on, we'd see that this graph would hit at 11.25. So the equation of the green equation is going to be y is equal to, remember this -5/4, -5/4 x plus the b value, which is 11.25, or 11 and 1/4, right? 11 and 1/4. Or we can write that, please forgive me for being all super mathy, 11 and 1/4. We can write that as a similar improper fraction as 45/4. Okay. And so what I'm saying is that the answer to this question is 5/5. So if we were to plug 5 and 5 into this equation, it would work out. So if I were to plug 5 and 5, I'm saying that 5 and 5 is a point. 5/5 is the orthocenter. Is it orthocenter? I'm sorry, the centroid. Sorry about that. 5/5 is the centroid, so I'm going to plug in. I see orthocenter here. That's what's getting me crazy. Stay with me. 5/4 times 5 plus 45/4 should equal 5. That's what we're getting. Let me see. I know it's kind of hard to see this. Let me make it black so you can see a little better. So we've got that, and if we were to do the math, 5 times -5 is going to be a -25. -25. -25 plus 45 is going to be a +20. And then I have 20 divided by 4, and that's 5. So in this case, I really just wanted to go through finding the equation of a line given 2 points, because it's something that's going to come up again. All right? Thank you guys for going through that with me. I just thought it was important. Now I'm going to erase it so we can see what our next theorem is about the orthocenter. So I'm going to erase all this stuff. And let's have some orthocenter talk. So orthocenter, the orthocenter we described before is where all the medians meet. And so our orthocenter theorem is this. The lines containing the altitudes of a triangle are concurrent, and they're going to meet at a particular point called the orthocenter. And we talked a little bit earlier about the orthocenter not necessarily being in the middle of the triangle, or not necessarily being inside the triangle. So the lines containing AF, CD, and BG intersect at point P, and that's the orthocenter. So that's not really a theorem. I said it was, but it's really just a definition, which we're comfortable with. And so now we're going to find the orthocenter in this example.